Hello everybody, we're on to Algebra 1 Credit 2. This is all about linear functions. Let's give you a few hints for day 1. Okay, in day 1 you're going to be watching the introductory video, making your prediction, and watching the solution to it. You can do that on your own. Let's jump into this first question. So this is about selling credit cards. A company offers its employees to collect applications. They'll give them a commission for collecting those. So they give them this daily pay, and we're looking at, in this case, Barry. He's getting a daily pay of B for the number of applications he collects in by this rule. So this is Barry's pay. It's equal to $20 plus $5 times the number of applications that he collects. So this is a functional relationship, and our independent variable is n, right? So that's the value we're going to plug in and find out what is this dependent variable. So Barry's daily pay is dependent on how many applications he gets filled out. Okay, so go ahead and fill out this this table based on its n and b values. So n and b represent this pair of numbers that makes this function true. So when I plug in 0, what is the value of b that would make this equation true? So I plug in 0 for b, and I get 5 times 0 plus 20 is b. So that means b would have to be 20, right, for this to be true. So for 20 to equal 20 to be true, b has to be 20. And then you're going to do that for each one of these. So you're going to plug in this value and find out what does the b value have to be. So I plug in 1 for n, I get 5 times 1, which is 5, plus 20, so that should be 25 for the next one. And so you're going to do that for each of those, and then we'll go on to the next part. So you're going to compare the pattern of change shown in the table with that shown in the graph below. So what you're going to do is you need to check a few points here, and are these points matching up with the points that are in the table? So you can check this one. It's 0, 20, and then the next one, well, halfway between 4 and 0 would be 2. So this is 2. Some people might be confused and think this is a 1 and this is a 3, but no. This is a value of 2 because we have to have a constant increment here. So this goes 2, 4, 6, 8, right? So this is 2. And up here, this is to have a constant increment this way. Let's see, for 20, that would have to be 10 each time, right? So half of 20 is 10. So this would be 10, 20, 30, 40. So this right here would be 30. So this point is 2, 30. So compare those points. Do they match up with the table on the previous side, and then justify your answer. Okay, and then you should be able to answer these questions that relate to the graph and the table. Then we come up to a question about Sherry. So Sherry works, instead of giving you the function relationship, they gave you the table of values. So does this table of values, is this a linear function? So you want to compare, do the rates of change for each step, are they a constant rate of change? That's what a linear function does, is it has a constant rate of change, that each step it constantly goes up by the same amount. And or even if you looked at a whole so from any 2 points, does it have a constant rate of change? And this comparison of how does it change in this one direction, so the change in y over the change in x. So is this a constant rate of change? And then that would make it a linear function. Okay, and then since there is a constant rate of change, you want to find out what are the halfway points. Can you figure out, like, if it's constantly going up by an amount, what is it if it goes half a step up, right? If it goes from 10 to 15 instead of 10 to 20. So it would also go a proportional amount to be filled in there. Okay, and then more on building the table. So talking about change in pay and what is the rate of change. So the dollar per sale is this change in. Actually, it might be flipped the other way around, right? So the dollars would be on top. So you put dollars per sale, right? So you want to make sure your rate is written in the right order. So you want to put how is the change in pay over the change in sale. That's what the per means. Per means this part is on top and this part is on the bottom. So that's just a little hint for you. Okay. Then they give you a bunch of different rules here, and you want to find out which rule represents that table of values that we just made, or the chart. So check a couple of values. All you need to do is really check two values, so one or two pairs of values. So if this pair, this N and C, does it fit with the table over there, then does this N and C fit with the table over there. If you can get two values that match up, then that's all that you can do. Is two values will prove that it's a line because it has a constant rate of change everywhere. So if you can get two values to match up with the table on the other side, then that rule is the right rule. So check those and see what you get. Going on down to C. So two things you want to check when comparing a function. So these are the symbolic representations, and this is the graph, right? So what you're going to do is match each function rule with its graph. And the two things that you want to check are, one, you want to check the initial condition. So where is it starting at? That's called the y-intercept, right? So it's starting when our n value, so this is n, and this is our a, b, or c, right? That's our function value. So when I plug in n equals 0, what do I get? So n equals 0, n equals 0 makes that 0, right? 2 times 0, anything times 0 is always 0, so it just drops it out. So you just have to look at what is the part without the n, and that's going to be your y-intercept. And what is the part without the n? What is the part without the n? So you can find out what is a y-intercept, and then the second thing you want to check is that rate of change. The rate of change is how much is it going up at each step? Is it going up faster or slower, right? So that means that, you know, as you increase n from 0 to 1, right, we're adding 2 more to it, and we're going to 2, right, it's 2 more to it. So the multiplier on the n tells you how much we're going up each step. That is the rate of change. This number, which is the coefficient of n will tell you how much it's going up and the rate of change. So you want to check, and that's the slope of this line over here, representing the graph, is that rate of change. Okay, so check your initial condition, check your rate of change, and that will help you determine how the graph should look. Okay, more filling out tables. You're gonna this one here, it says Emily bought this television for $480, and then she's going to try to pay it off in 12 months, but she's only paying the minimum payment of $20. So you want to make a table of values based on this situation. So imagine that you go into the store. As soon as you buy it, you're paying so much for it, right? And you have that on credit. And then over time, you're going to try to pay that off. So each month it's going down by $20 that you owe, because it has 0% interest for 12 months. So you want to try to pay it off before the interest starts hitting you. So like right now, you just have to pay back the $480. But when interest comes in, then you have to pay more than the $480 back. So that's kind of one thing about credit cards, is they take out a bigger bite than you start with, if they have an interest rate. So if you can pay it off before the 0% interest ends, then you never pay more than $480. Okay, so we want to analyze the situation and make a table of values, put it on a graph, and then we're going to see at 12 months, has she paid it off yet? If that line is still above 0, right, then she still owes more money. But if it's dropped below 0, that means she's paid it off, right? So there's kind of two situations. It could be like this, and then at 12 months she still owes money, right? Or it could be like this, where she paid it off back here, like so at 12 months. So she paid out maybe like back here at 6 months or something like that, wherever it crossed the 0 mark, right? This is the amount she owes. So right here, she starts off at some point, she owes some amount of money, and then every month she's paying off $20, right? So does it get down to zero before the 12 months or not? Then actually we want to make a rule for this situation. How much does Emily owe at some given time? So at a given month, we can just plug in the value of the month and find out what she owes. So this is a powerful way to use functions, is to be able to put them into a rule so that any month we can figure out what she's going to owe. Okay, so all you have to do is check a couple of values to see if it matches up with that table above. So when you put in 0 months, does it match up with that value? When you put in 1 month, does it match up with that value? Okay, it's a little hint there for you. And more questions about what you just did there. Okay, so explain your answers. And then these diagrams again, just like before, you're going to find out what is your initial condition and what is your rate of change. Okay, and that'll bring up day 2, so good luck with day 1.